Take a close look at this eye. Blue, bright, mesmerizing. Eye color is one of the first things we notice about a person. But what if your eye color determines more than just your appearance, but also how much pain you actually feel? Everyone has heard the claim that people with blue eyes are more sensitive to pain. But is it actually true? Can a simple pigment in the iris really affect how we experience suffering? The internet is literally overflowing with articles on this topic. Millions of blue-eyed people around the world are asking this question. And today, we're going to settle this once and for all. We'll examine the history, science, genetics, and psychology behind this claim. We'll conduct a real investigation, worthy of the best detectives. From Scandinavia to the equator, eye color is distributed unevenly across the planet. And scientists have actually studied the connection between eye color and pain sensitivity. The arguments for and against are about to collide in a real battle, so let's begin. Myth or reality? Let's go! To understand where this myth came from, we need to travel far back in time. Even in ancient Greece, people believed that external body features reflected internal conditions. The theory of four humors linked temperament to physical characteristics. Medieval doctors tried to determine diseases and sensitivity by looking at the patient's eye color. In the Victorian era, light-eyed people were considered more delicate and fragile. Pseudosciences like phrenology and physiognomy only reinforced these stereotypes. Newspapers and magazines of that era eagerly published such theories. But the myth got its real boost thanks to genetics, specifically thanks to melanin. Melanin is the pigment that determines the color of our eyes, skin, and hair. People with blue eyes have significantly less melanin in their iris, while people with brown eyes have much more of it. It's a dense protective layer of pigment. A well-known fact, blue-eyed people are indeed more sensitive to bright light, while people with dark eyes handle bright light much more comfortably. And here's where the key logical leap happened. If more sensitive to light, then to pain as well. In 2014, this myth received a powerful scientific boost. Researchers from the University of Pittsburgh published a study that went around the world. They studied a group of pregnant women and their pain response during childbirth. Childbirth is one of the most painful processes the human body experiences. The results showed light-eyed women demonstrated a lower pain threshold. News channels instantly picked up this story. Social media exploded. Millions of reposts, likes, and comments. Like a game of telephone, the information got distorted with each retelling. The myth began to grow like a snowball rolling downhill. Bloggers and clickbait article writers added their own speculation and exaggeration. And so one small study gave birth to a massive myth with deep roots. So let's honestly examine the arguments in favor of this theory. The first argument is genetic connection. The OCA2 gene is responsible for eye color. This same gene affects melanin production throughout the entire body, including the nervous system. Melanin is present not only in the eyes, it's also found in the brain and nerve tissues. Some scientists suggest that melanin may act as a protective barrier for nerve cells. If there's less melanin, nerve endings may be more vulnerable to pain signals. The second argument, the connection with redheaded people. And this is no longer a myth. The MC1R gene, responsible for red hair color, has been proven to affect pain sensitivity, and redheaded people most often have light-colored eyes, blue or green. Studies have shown that redheads require 20% more anesthesia. This was published in the Journal of the American Dental Association. The third argument, experiments on laboratory mice confirmed the influence of pigmentation on pain. Mice with light pigmentation reacted to pain stimuli significantly more strongly, while mice with dark pigmentation remained much calmer. The fourth argument is related to endorphins, our body's natural painkillers. There's a hypothesis that endorphin levels may be linked to pigmentation levels. Less melanin, possibly fewer endorphins, lower pain threshold. The fifth argument is evolutionary. Blue eyes appeared when humans migrated north. In conditions of cold climate and short daylight hours, the body adapted. Less melanin meant more vitamin D absorption from scarce sunlight. But perhaps this evolutionary trade-off came with a side effect: increased sensitivity. The sixth argument, patient survey data from hospitals. Light-eyed patients more often rated their pain higher on a 10-point scale, while dark-eyed patients rated the same procedures with lower scores. Let's return to the Pittsburgh study. Light-eyed women in labor more often requested epidural anesthesia. Statistically, the difference was noticeable and amounted to several percentage points. The seventh argument, brain neuroimaging during pain stimuli. There's a phenomenon called genetic pleiotropy, where one gene affects multiple traits simultaneously. Supporters of the theory are convinced there's enough evidence. At first glance, the pile of evidence looks impressive, but wait. Now let's turn on our critical thinking and look at the other side, because upon closer examination, these pieces of evidence reveal serious cracks. The first problem, sample size. Most studies were negligibly small. That famous Pittsburgh study, it has numerous limitations. It involved only 58 women. 58 out of 7 billion people. The second problem, a fundamental error. Correlation does not mean causation. In summer, ice cream sales rise and shark attacks increase. But ice cream doesn't cause shark attacks. The third problem, many attempts to replicate these results have failed. Large meta-analyses with thousands of participants reached entirely different conclusions. The result? No statistically significant difference between eye color and pain threshold. The fourth problem, pain is incredibly complex. It depends on dozens of factors simultaneously. Stress and anxiety significantly increase pain sensitivity in any person. Sleep deprivation can lower the pain threshold by 30%, regardless of eye color. Culture also plays an enormous role. Different societies express pain differently. In some cultures, it's customary to endure silently. In others, to openly express suffering. The fifth problem, the placebo effect. Our expectations literally change our sensations. If you believe you're more sensitive to pain, you actually start feeling more pain. This is called the nocebo effect, when negative expectations worsen actual sensations. A blue-eyed person who has read articles about their sensitivity will come to the doctor already anxious. The sixth problem, the gate control theory of pain, shows that the brain itself regulates pain signals. Hundreds of genes are involved in pain perception, not just one or two. The SCN9A gene, now that's a real pain gene. It encodes sodium channels and nerve cells. People with a rare mutation of this gene don't feel pain at all. And eye color has nothing to do with it. The COMT gene affects the breakdown of pain neurotransmitters. That's what actually determines sensitivity. Twin studies have shown, even with identical eyes, pain thresholds can differ. Physical activity raises the pain threshold. An athlete of any eye color tolerates pain better. Meditation and mindfulness practices have been proven to reduce pain perception. Again, for everyone. Age also affects pain sensitivity, and it works in both directions. The hormones estrogen and testosterone play a much bigger role in pain perception than eye color. The seventh problem, publication bias. Sensational results get published more often. Researchers may unconsciously select data that confirms their hypothesis. Real science requires multiple verification, reproducibility, and large sample sizes. The scientific community as a whole does not confirm a direct link between eye color and pain. A beautiful myth, sadly, bursts when it meets the sharp needle of real science. The arguments against are significantly more numerous and much more convincing. And here comes the moment of truth. Time to deliver the final verdict. Drum roll, please. The verdict? Myth. The claim that blue-eyed people are more sensitive to pain is a myth, but with one important caveat. This is not an absolutely black and white situation. On a scale from complete myth to complete reality, the needle points closer to myth. There's a tiny grain of truth. Melanin is indeed present in the nervous system, but the connection between eye pigmentation and pain sensitivity is weak and indirect. Simplifying the incredibly complex pain perception system down to eye color is a gross error. Pain is a cocktail of genetics, psychology, culture, experience, hormones, and dozens of other factors. There are incredibly tough blue-eyed people who win in the boxing ring, and there are dark-eyed people who cry from a paper cut, and that's absolutely normal. Your eye color does not determine your strength, endurance, or pain threshold. Our brain is the most complex structure in the universe. You can't reduce its function to a single pigment. Every person is unique. Your pain sensitivity is your individual fingerprint. Bottom line, eye color does not determine pain sensitivity. Period. Science defeats myth. And that's wonderful. The main lesson of today's episode, don't believe catchy headlines. Always check the facts, think critically, and ask questions. The internet is full of myths disguised as scientific facts. Stay vigilant. But wait, don't leave. We have something incredible for you. A bonus fact that will blow your mind. All blue-eyed people on the planet, all of them, descended from one common ancestor. This person lived approximately 6,000 to 10,000 years ago, presumably in the Black Sea region. He had one single genetic mutation that changed his eye color. And this mutation was passed from generation to generation, spreading across the entire world. This means if you have blue eyes, you're a distant relative of every blue-eyed person. All blue-eyed celebrities, all your blue-eyed friends, all connected by one genetic thread. This discovery was made at the University of Copenhagen. Professor Hans Eiberg and his team studied the DNA of blue-eyed people from around the world. They discovered that the mutation literally switched off the OCA2 gene, like a light switch. Think about this. One person person, one mutation, and hundreds of millions of blue-eyed descendants. If you enjoyed this video, hit like and subscribe to the channel. Write in the comments, what color are your eyes? And which myth should we debunk next? In the next episode, another incredible myth awaits us. You definitely won't guess which one. Thank you for being with us. See you next time on the Myth or Reality channel.